sine, cosine, and tangent. Those are the trigonometric ratios. So the ratio of the adjacent to the hypotenuse is cosine. So cosine is adjacent over hypotenuse, or A over H. Adjacent, hypotenuse. And then sine is opposite over adjacent, or hypotenuse, opposite over hypotenuse, so O over H. Okay. So ka toa. This is sine is opposite over hypotenuse. This is cosine is adjacent over hypotenuse, and this is tangent is opposite over adjacent. This is a way to remember them. There's another way that I know to remember them, but you have to remember that it goes sine, cosine, tangent. But we can talk about Oscar had a heap of apples. Opposite over hypotenuse, adjacent over hypotenuse, opposite over adjacent. That's the way they taught it to us in high school, but it didn't tell you sine, cosine, tangent. You had to remember it goes sine, cosine, tangent. This is nicer because this is sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. Sokatoa. Yeah, like soak your toe, sokatoa. I don't know. Just a way to try to remember it. Now, we never take sine, cosine, and tangent of the right angle, only of the acute angles, so the other two angles. Okay, this is the hypotenuse. This is always the hypotenuse. Now here's what happens. If I want to use this angle here, this is opposite, and this is adjacent. But if I'm talking about this angle right here, this is opposite, and this is adjacent. So the angle you're talking about, if you draw an arrow out of it, points to the adjacent side, or to the opposite side. The hypotenuse is always the hypotenuse. It's just opposite and adjacent that change depending on the angle you talk about. All right, so how do we do this? All right, if I want to find the sine and cosine of x, okay, if I'm talking about x, this is the opposite, and this is the adjacent, right? Because it's going to point to the opposite. So the sine of x, sine, so opposite over hypotenuse. So 9 over 15, which you'll divide, and you get 0.6. Cosine of x, I'm going to put that in there, is adjacent over hypotenuse, ka. So ka. So that's going to be 12 over 15. So if I divide that, I get 0.8. And just as a refresher, tangent is opposite over adjacent, toa. So tangent would be 9 over 12. Is 0.75. did all that. If I put it in the calculator, okay, so I would put 0.8125, and then I would push the inverse button, and then that cosine -1 button, and I get 35.7. So see, we were really close. Here I have my angle. This is the opposite, right? And here's hypotenuse. So I have opposite over hypotenuse, that's sine. So the sine of 57 degrees is equal to x over 12. So I'm going to go to my calculator or table, and I'm going to take 57 degrees, and I'm going to find the sine of it. That's 0.8387. And that's equal to x over 12. And multiply both sides by 12. So I'll multiply that by 12. So x is equal to 10.1. Alright, we have cosine and sine for A. Okay, I have the hypotenuse and I have the side. I need to find this side right here. So 12 squared plus b squared equals 15 squared. So 144 plus b squared is equal to 225. Subtract 144 from both sides. And b squared is equal to 81. So b is 9. Okay. So I don't have room. Cosine of A. Okay, I'm gonna hold on. Does everybody have this part?
Adjacent over hypotenuse, right?
Yeah. Yeah, cosine is adjacent over hypotenuse. So it's Ca, right? C-A-H. So adjacent is 12, hypotenuse is 15. So it's 12 over 15, which is 0.8. And the sine of A is opposite over hypotenuse. So it's 9 over 15. So it's 0.6. Okay, I'm going to need to find the hypotenuse. So 5 squared plus 12 squared equals c squared. So 25 plus 144 is equal to c squared. So 169 is equal to c squared. So c is 13. So this right here is 13. Cosine of A is adjacent over hypotenuse, so it's 5 over 13. So it's 0.3846. Sine of A is opposite over hypotenuse, so it's 12 over 13. So it's 0.9231. Okay, I want to find x. I have this angle here. This is the hypotenuse. This is adjacent, right, to this angle. This would be opposite. Adjacent over hypotenuse is cosine. Right? So I have the cosine of 33 is equal to 15 over x. Okay, to find the cosine of 33, I would either go to a table or I can use this calculator. It's 0.8387. Okay. So x is equal to 15 divided by 0.8387. So it's 17.9.
I have a question.
Yeah.
For this one, why did we put a 15 over the, because we multiply by x, right? To cancel it out?
Yeah.
And then we put it under?
Yeah.
Okay.
So what you did basically is, if you have it set up like this, I'm skipping 2 steps. Because the step is you multiply both sides by x, and then you divide both sides by 0.8387.
Yeah.
So you can just, when you have it set up like this, you can just take this number and switch them.
Okay.
Okay, so here I have x, and I have hypotenuse and opposite. So it's sine. So sine of x is equal to opposite over hypotenuse. So 5 divided by 8, so sine of x is equal to 0.625. Now I can either go to that chart, let's see if it's got that on there. Yeah, okay, so I have 6157 or 6293. 6293 is going to be closer, right? So it's about 39 degrees. That's right here. So I can say x is about 39 degrees. Or I can put it into the calculator, press that inverse button, sine, and it's 38.7. Okay, last one. I have opposite and hypotenuse. Sine is the opposite over the hypotenuse. So the sine of 41 degrees is equal to x over 3. So I take 41 degrees, and I take the sine of it, or go on the chart, and it's 6561, right? Yeah. Is equal to x over 3. Multiply both sides by 3. So it's 1.98, so it's 2.